Hello viewers, I'm Kausalya. Today we are going to solve problems 8 and 9 in exercise 13.1. The problem is from a solid cylinder whose height is 2.4 and dia 1.4 centimeter. So here we are having a cylinder, right? And the height of the cylinder is 2.4 and the diameter of the cylinder it is 1.4, right? So a conical cavity of same height and same diameter is hollowed out. So we are having a cone, right, which is of the same diameter and same height. So find the total surface area of the remaining solid to the nearest centimeter square. So here we have to find the total surface area, right? So you see, I'll explain this concept, okay, with a tumbler here. You see, let this be the cylinder, right? Let this be the cylinder and we are having a cone inside it, right? And this is the cone which is placed inside this cylinder, right? So here, while calculating the total surface area, what are all the parameters you will include? You will include the total, that is the curved surface area of the cylinder, right? This entire area. Apart from that, you see, we do have a base here, right? So what about the base? It is in the form of a circle. So here, while calculating the total surface area, you have to include the curved surface area of the cylinder as well as the base of the cylinder. And here we are having a cone. So here you have to include the curved surface area of the cone also, right? So totally 3 parameters have to be included. So this is what I had written here. You see, the total surface area of the solid includes curved surface area of cylinder plus base of cylinder plus curved surface area of the cone. So just we know the formulas, we have to substitute the parameters, that's it. So here you see, curved surface area of the cylinder is, it is 2 pi RH. The value of diameter is, it is 1.4. So radius is 1.4 by 2 and height is 2.4, right? Next is base of the cylinder. It is nothing but it is in the form of a circle. So here the area is pi r square. Again the value of r is 1.4 by 2. So just substitute it. And the next one is cross-sectional area of the cone. Here the formula is pi r L. Right. L is nothing but the slant height. So here the formula for L is, it is nothing but square root of r square plus h square. Right. Again the value of r is same, right? Because they are clearly given in the problem. The diameter and the height of the cylinder and the cone are same, right? Therefore here the radius is, it is again 1.4 by 2. So here I had written it as 0.7 directly. Plus the h is, it is 2.4 square, right? So just solve this and finally we are ending up with the answer as the value of L is 2.5 centimeter, right? So now we are just going to substitute the values, right? So curved surface area of the cylinder, base of the cylinder and curved surface area of the cone, right? So here the common parameters are, you see, we have pi in all the 3 terms as well as this 1.4 by 2. So just take the common terms outside and these are all the remaining parameters, right? So here once you solve, finally we are ending up with that is 17.6 centimeter square. But in the problem they had asked to find the surface area to the nearest centimeter square, right? We have to round this off. So 17.6, right? Since if it is like 17.4, we have to close this as 17, right? We have to turn this number as 17. Since it is 17.6, that is, it is greater than 0.5, we are rounding it off to 18, right? So here the answer is 18 centimeter square. So problem 9. A wooden article was made by scooping out a hemisphere from each end of a solid cylinder as shown. If the height of the cylinder is 10 and its base of the radius is 3.5, find the total surface area. So here what is the thing? You see, we are having a cylinder, right? We are having a solid cylinder and we are having a hemisphere from each end, right? So here the two shapes are, one is cylinder and another one is hemisphere, and that too the hemispheres was made by scooping out a the article was made by scooping out a hemisphere from each end of the cylinder. That is, a cylinder has two ends, right? From both the ends of the cylinder we had removed, that is, we had scooped out, okay, we had formed a hemisphere, right? If the height and radius of the cylinder is given, we have to find the total surface area. So here this is the diagram, right? We have a cylinder, right? And on both the ends of the cylinder we have a hemisphere, right? So we have to find the total surface area. So here again you see from this diagram we can easily tell, right, what will be the total surface area. The total surface area is, it is the curved surface area of the cylinder, right, plus area of this hemisphere plus the curved surface area of this hemisphere, right? And since these two hemispheres are similar, right, we can write it as, wait, while solving I'll explain, okay? No need to confuse you now. So I hope you can understand this problem clear, right? We have a cylinder and we have two hemispheres on both the ends, and now we have to find the total surface area. So regarding the cylinder, it will include the curved surface area, right? And then we are having two hemispheres, so we have to find the area of two hemispheres. And when you add all these values, then finally we will be ending up with total surface area, right? So the curved surface area of the cylinder, it is given by the formula 2 pi RH, right? Plus, you see, we are having two hemispheres, right? So here I had written the formula as 2 times of curved surface area of hemisphere. Or else you can write CSA of hemisphere 1 plus CSA of hemisphere 2, right? Both are same. So here what is the formula for hemisphere? It is 2 pi r square, right? So here I am having 2, so 2 into 2 pi r square. So again when you keenly observe, you see the radius is common for the hemisphere as well as for the cylinder, right? Because you see here what all the thing which is given, the radius of the cylinder is 3.5. So obviously you see the radius of the hemisphere is also 3.5, right? So we can take r as a common parameter outside. So here when you look at these two terms, right, or you can go with this, it will be easy, I believe. So here you have 2 pi and here also 2 pi, right? So take 2 pi outside. Apart from that, here I am having an r and here r square, so I am taking r outside. So the remaining parameters are h plus 2r, right? So now just substitute the values, that's it. So the value of r is, it is 3.5 and the h is, it is 10. So just substitute it, and when you simplify, you see, first you have to multiply this. 2 into 3.5, this will give you 7, and 10 plus 7 gives 17, right? So when you simplify, finally we are ending up with the answer as 374 centimeters square, right? So here you can cancel these two terms, 7 and 3.5. Okay, it is 0.5 times. So again to simplify what I have told you, if you have 0.5, you can write it as 1 by 2, right? So wait, let me show you here. You see 2 into 22 into, this 0.5 can be written as 1 by 2 into 17. Right, again this 2 and this 22 will cancel, it will make 11. So again 11 2s are, it is 22, right? So 22 into 17, so 7 2s are 14, 4 remainder 1. 14 plus 1, it is 15, and here it is 22. So here the answer is, it is 374 centimeters square, right? So that's all. If you have any doubt, let me know in the comment section. Thank you.